So we look at proportions and see how proportions work. So basically what happens is if you manipulate the value of something, we're going to check how it affects the value of something else. So for example, if you, let's say you have a triangle, uh, so seeing, for example, if you manipulate the height, how would that affect the area, right? So that's how we use proportions. Now, let's say, for example, we have a triangle, and we know that the area of a triangle is 1 over 2 base times height. So you have a triangle, you have the base, and you have the height. If, for example, you triple the height, how is that going to affect the area? So you have the original triangle, and then let's say you triple the height of this triangle. Now, to check the area of the new triangle, what you do is you have the area of the original, so it's a is equals to 1 over 2 base times height. Now, in the new one, the area is going to be 1 over 2 base times the new height, which is 3h, right? Now, if you simplify this, if you open the brackets, you get 1 over 2 bh times 3, which means it is 1 over 2 bh and 3. So this is the area for the new triangle, right? And if you compare this to the original, we can see that it's basically the same thing, but tripled. So it's 3 times the original, right? So the new area is going to be triple the original area. So that's how height affects the area in this example. Now let's say, for example, you have a circle. Let's say the circle, the area of the radius of the circle is increased by 25%. How will this affect the area? So let's say, for example, you have a circle. You have a circle that looks something like this. The radius, let's say, for example, is r. Now let's say you have a new circle where the radius is increased by 25%. So a 25% increase means you would write it as 1.25 r. That means a 25% increase. Now the area of a circle is pi r squared. To find the area of this new circle, it's going to be 1 over 2, it's going to be pi r squared. Now in this case, we know that the radius is 1.25, so it's 1.25 r squared. So we're using the original formula, which is pi r squared, right? So that's the formula, and we're simply plugging in the value or the values for radius, right? That's r, this is 1.25 r into radius. Now if you solve for this, you will get the square of 1.25, which is 1.5625, and everything else remains the same. So we have pi here, and then it's r squared, right? So the original area was pi r squared, and the new one is 1.56 times the original. So we can write this as the new one is 1.5625 of the original area, which basically means it is a 56.25% increase over the original area, right? So if you increase the radius by 25%, the area is going to increase by around 56%. Let's look at another example. In this case, we have a rectangle. So it says the length of the rectangle is increased by 20%. Let's say this is the original rectangle, length and width, and then we have a new rectangle that looks like this. So the length is increased by 20%, which means you can write that as 1.2 L. So it's 1.2 L, a 20% increase. The width is decreased by 20%, which you can write as 0.8 W. Decreased by 20% means you write that as 0.8. So the area is going to be LW for this one. For the new one, we can say its length times the width, so it's 1.2 L multiplied by 0.8 W. 1.2 times 0.8 is going to be 0.96 LW, and this represents the original LW, which means you can write this as the new area is equals to 0.96 times the old area, which means that the new area is 4% less than the original, right? So that's how you would depict this. So if you increase the length by 20% and decrease the width by 20%, the area is going to be 4% less than the original. Okay, next. So in this case, we have the volume of a cube is tripled. the length of each side must have been increased by what percent? So we have a cube, that is a cube. The volume is triple, so that means it's going to be much bigger. It'll look, let's say, something like this. Let's say the length of each side here is L, and in this case it's capital L, uppercase L. So that is, so to find the volume of a cube, it is L cubed, and for this one it's going to be L cubed. Now, it says that the volume is triple, which means that the new volume is 3 times the original. So we can write this as V is L cubed. So I can take this and put this into here. So Vn becomes 3 times L cubed. And I know that the new one is uppercase L. So that's L cubed is equals to 3L cubed. Now we need to get rid of the cube. So we need to cube root both sides. So you cube root this side and you cube root this side. When you cube root that, this is going to cancel with this. So you get L is equals to cube root of 3, and then this cancels with this, L cube and cube root. So you're left with just L. Now if you find the cube root of 3, that is going to be 1.44. So L is equals to 1.44 L, which means that the new length is 44% greater than the old one. So there's a 44% increase over the old length. And that's what's going to triple the volume. Okay, next we have some questions. Question 1, it says that this is the formula for power. The voltage is going to be halved. What's going to happen to the power? So that's the formula, that's the original. And then let's say I make a new formula for the new case. So it says that the voltage is halved. So you can write this as 0.5 V squared. That's the new voltage divided by R. Everything else remains the same. If you solve for this, you're going to get 0.25 V squared over R. And we can write this as 0.25 V squared over R. Now this is the original, which means you can write this as P is equals to 0.25 P, and that's the new power, right? That's the new one. So we can write this as it's a 25%. It's 25% of the original, or you can say it's a 75% decrease. Or in this case, we will say that it is a quarter of what it was, because 0.25 means 1/4. So you can write this like this as well. So it's a quarter of the original. Next, it says that Julie has a square fence. She decides to expand her garden by making each side of the fence 10% longer. So we have a square fence. She makes it 10% longer. So we need to find the area. How would the area change? So let's say that this is the original length. If it's 10% longer, that means you would write this as 1.1 L. 1.1 L. The area for this one is going to be L squared. The area for this one is going to be 1.1 L squared, right? So the length times the length. Now, if you square 1.1, you're going to get 1.21 L squared. That's the new area, which means it's 1.21 means a 21% increase over the original, because the original is L squared and this is the original. So it's a 21% increase. So you would say 21%. Question 3 says we have a right circular cone with a base radius of R and a height of H. So you have a cone that looks something like this. The radius is R, the height is H. It says that the radius is decreased by 20%. So now we have the new one where the radius is going to be slightly smaller and the height is going to be longer. So that's it's going to be 0.8 R, because the radius is decreased by 20% and the height is increased by 10%. So height is going to be 1.1 H. Now we need to compare the volume. The formula for a cone, for the volume of a cone, is 1/3 pi r squared H. So that's the original volume. If we find the new one, it's going to be 1 over 3 pi. The radius is 0.8 r. That's the new radius, and the new height is 1.1 h, and this is going to be squared. Now, if you solve for this, basically you just have to solve what's in the bracket. So 0.8 squared times 1.1. Everything else remains the same. So I'll just write that for you. It's 1 over 3 pi r square h. That stays the same, and this is what's new. 0.8 squared and 1.1. So we just have to multiply this. So 0.8 squared times 1.1 is going to be 0.704. So you can write this as 0.704 times the original. And that is going to be your new volume, right? So you can write this as this. So we can see that the new volume is 0.704 of the original, which means it's around 70% of the original, or around a 30% decrease. So around a 30% decrease means it's going to be D, right? So the reason for that is because 100% minus 70.4% is going to be 29.6. So it's actually a 29.6% decrease. Okay, next. Question 4. So we have a trapezium. That's the formula. It says the lengths of BC and AD are halved. BC and AD are halved. So how would the area change? So that's the original. So the new one is going to be, everything else remains the same, but the lengths of BC and AD would be much smaller. So you can write this as 0.5 B1 and 0.5 B2. In H remains the same. Now that's the area for the original. The new one is going to be 1 over 2, 0.5 B1. Sorry, the height is doubled, so it's going to be 2h doubled. So 0.5 B1 plus 0.5 B2 multiplied by 2h. Now if you solve for this, we get 1 over 2. You can factor the 0.5, so 0.5 can be factored. We get B1 plus B2, and then the 2 can be factored here. You can bring the 2 here. Now if you solve for this, 2 times 0.5 is 1, which means it's 1 times the original, B1, B2, and H. Now as you can see, nothing actually changed, because 1 times the same thing, it's going to be 1. It will be the same thing. So AN is going to be the same thing actually, right? B1 plus B2 and H, which means nothing actually changed. It is the same. So B would be correct. The area would remain the same. Question 5. It says we have a sphere that is 4 times bigger than the one Kevin has. Calvin's sphere is how many times greater in length than the radius of Kevin's sphere? So you have 2 spheres. This is one sphere and this is another. So we're basically just comparing the volume and the radius. Let's say the radius of this one is r, and the radius of this one is uppercase R. The volume of this one is V. The volume of this one is 4V. So it's 4 times the original. Now the formula for a sphere is 4 over 3 pi r cubed. And for this one, it'll be 4 over 3 pi r cubed, because that's the new one. And then we can say that this is equals to, because it's equals to 4 times this, we can substitute Vn. So you can say 4 over 3 pi r cubed is equals to 4 times this. So 4 times 4 over 3 pi r cubed. Now in this case we can cancel 4 over 3 pi, 4 over 3 pi, which means we're left with cube r cubed is equals to 4 r cubed. We can take the cube root on both sides. Cube root of this, cancel this, and this. We get r is equals to cube root of 4 times r, because this cancels with this. Now, if you find the cube root of 4, that is going to be 1.587 r is equals to r, which means it is around a 58.7% increase over the original, right? So the new radius is around 58.7% greater than the original. So 58.7, which means it's around 59. So it will be B. Question 6. We have a triangle. It is the lengths of the sides relate to one another if a new triangle is created by decreasing s such that the area of the new one is 64% of the original. So that means we have another triangle. Let's say we have another triangle that is smaller. It's 64% of the original. So AN is 64% of the original. So let's say the length of the new one is x and x. Now, to find the area for this triangle, it's going to be 1 over 2 s squared. To find the area of this one, it's going to be 1 over 2 x squared. Now, because it's equals to 64% of the original, I can make this equal to this. So I can say 1 over 2x squared is equals to 0.64a, and then I can substitute a, which is 1 over 2 squared. So you can write this as 1 over 2x squared is equals to 0.64, and then that's the original area, 1 over 2s squared. You can cancel 1 over 2 both sides, so you're left with x squared is equals to 0.64s squared. You can take the root on both sides to cancel out the squares. So take the root, you get x is equals to, because this cancels with this cancels with this, and then the root of 0.64 is 0.8. So this is what you're left with, which means x is 20% less than the original length. So you would say it's 80% of the original length, or a 20% decrease. So you would say it's a decrease of 20%. Question 7. So that's the formula for the total amount of energy. L is luminosity, D is distance, B is brightness. It says if one star is 3 times as far away from Earth as another, twice as bright. So 3 times as far away means 3D, because D is distance, and twice as bright means 2B. So how many times greater it is the luminosity? So that is the original formula, and then this is the new one. The new one has a distance that is 3 times the original, and the brightness is 2 times the original. You can factor the 3 squared, so we can factor 3 squared and 2, right? Because that's what has been included. So you can write this as 3 squared, 2, separate that, and then you can write the formula, which was 4 pi d squared b. I just removed the 3 squared and the 2, because that is what we included. Now if you solve for this, 3 squared is 9, 9 times 2 is 18. So this is 18, 4 pi d squared b, that's L, that's a new L, so new L is equals to 18 times the original. So it'll be 18 times that. And then final question, question 8 says, astronomers see 2 equally bright stars, star A and star B, but the luminosity of star A is 1/9 of star B. So luminosity of A is 1/9 of star B. So the distance of A is what fraction of the distance of B? So you can use the formula for this. We're comparing the distance. Everything else remains the same. So that's the formula. I'll use that here. 4 pi d. So because we're comparing the distance, I'm going to say dA squared b, and this is going to be 1 over 9 4 pi dB squared b. So I only added distance A and distance B. Everything else remains the same. You can cancel 4 pi and b, 4 pi b. You get dA squared is equals to 1 over 9 dB squared. You can take the roots on both sides to cancel out the squares. Root on this side, root on this side. This cancels with this. You get dA is equals to root of 1 over 9 is 1 over 3. And then this cancels with this for dB. So you get that the distance of A is a third of the distance of B. So you would say 1 over 3.